Design of a new multivariance solar panel. Deployment system, MVSPDS. Abstract Multivariance Solar Panel Deployment System, MVSPDS, is defined as the satellite deployment system which can change its orientation according to the power supply required for the satellite or power supply source available to the satellite. To deploy the solar panels completely, it is necessary to design the deployment mechanism which has high precision and reliability. So this method of deployment will not only provide the said benefit but also it will allow a wide range of application. Consequently, the analysis on the dynamic characteristic of the deployment mechanism must be done at an initial design stage. The design effectiveness and structural safety of the proposed solar panel module were validated by launch vibration and in-orbit environment tests at the qualification level. In this paper, the complete design of a new multivariance solar panel deployment system in a satellite is proposed, where I have inculcated various deployment methods and proposed a new method of satellite deployment. The complete design is done in the Autodesk 360 software, educational license, where the design and animation method are extensively used to make this possible. It will be clearly depicted from the design that the structure is very compact during the process of orbit insertion. Yet when it come into working it definitely works according to the power need of the satellite. For an example, when the satellite needs less amount of power it will transform itself in such a way that the amount of power generation will be less. On the other hand, when the satellite needs more power, then the solar panel will change itself in such a way that it will have the maximum surface area, as a result of which the power generation will be maximum. Moreover, the variety which provides is really unique, as it also has the power to change its solar panel into different structure. For an example, it can change itself into a circle-like structure, it can change itself in the canister to form another structure, and moreover it will work completely according to the need if programmed properly for space flight mission. And hence can give rise to a wide variety of different deployment methods. Keyword: satellite, solar panel orientation, solar panel deployment, multivariance solar panel. Introduction. Multivariance solar panel deployment system, MVSPDS, is defined as the satellite deployment system which can change its orientation according to the power supply required for the satellite or power supply source available to the satellite. The sole purpose of this project is based on designing of a new multivariance solar panel deployment system. Solar technology can be a political football on the ground, tossed around and tackled often in space. It encounters little opposition. For space-limited operations many components were successfully miniaturized. The stabilization types changed from simple spin stabilization and passive stabilization using permanent magnets to fully 3-axis stabilized spacecraft. Some recent missions also validated propulsion systems for satellites. Despite this significant progress, two problems remain unsolved due to the small surface area of satellite. The commonly used body fixed panels produce insufficient energy and similarly provide too little surface area for adequate energy dissipation. This project will address the basic arrangement along with various variation in the arrangement of solar array. One of the possible solutions is the use of deployable structures to increase the available surface area in many possible ways and with different transformation mode. This paper deals exclusively with a new multivariance structural design of a single satellite, although dual system is possible. There are many aspects of the design, construction, and operation of such a space solar power system that are outside the scope of this project, e.g., the design of lightweight photovoltaic cells, large-scale phased arrays across independent spacecraft, integrated circuits for microwave signal synthesis, and formation flying. Image of basic deployable structure. However, the concern herein is purely structural design and its deployment, and, as such, only relevant metrics will be considered, which include the operation of the solar array. This paper will present a preliminary structural design of a spacecraft that has less area with small packaged volume, and is sufficiently stiff. The developed design is based on a generic satellite mission and an orbit with an altitude of 400 kilometers. The satellite is assumed to be 3-axis stabilized. The panels are usually in stowed position to avoid damage during the launch phase and are deployed later on when the satellite reaches its desired orbit. In general, mechanisms on board of satellites are limited to small dimensions and are required to be extremely lightweight by the satellite launch system. Working in an environment with no possibility of later corrections or modifications requires a high functional reliability and repeatability. The two major impacts on the satellite are the compatibility of the thermal heat. IJERT 10 is 050141 www.ijert.org. This work is licensed under a Creative Commons Attribution 4.0 International License. Expansion ratios and the large occurring temperature changes. These result in thermally induced stresses which might cause cracks in components or delamination of glued components like solar cells. 2. Literature review. This section covers the literature review of solar arrays used and the method of deployment for space applications. The first section gives a brief overview of the principal solution options. Afterward, currently used techniques are evaluated to determine the most valuable direction of development. For a systematic review of existing solar array systems, the complete system of a deployable solar array was split into several subsystems. Actuation mechanism for deployment. Guiding mechanism for deployment. Damping mechanism for deployment. Initial release mechanism. Actuation mechanism for articulating. Control mechanism for articulating. Solar cell technologies. Solar panel materials. Solution options were generated by analysis of current solar panel systems and research in scientific journals, patent databases, and books. The options originate from satellites ranging from small satellites to very large satellites, like the ISS or the Hubble Space Telescope. But his concept of design is completely new. 3. Solar cell. Although many types of solar cell are to be used, but it is recommended to use a triple junction solar cells because it has high efficiency and good radiation resistance. While the earlier discussed solar cells use just one NP junction, triple junction solar cells combine three material pairs to cover a larger part of the spectrum of the electromagnetic radiation. A possible combination is the three junctions are gallium-indium phosphorus, gallium-indium arsenide and germanium. Current solar cells provide a conservation efficiency of 28.3% and experience a degradation of 15% by 1 MeV in 33 years. Triple junction solar cells offer the highest conservation rate and a good radiation resistance. This enables this project of reaching the optimum power output from the solar cells. Therefore, triple junction solar cells will be used within this paper. Each panel contains 6 solar cells of 1 2V. Hexagonal shape is given to fit the 6 panel altogether, apt for design. 4. Design of single panel. Initial side of the panel is kept constant so as to keep the solar cell in a less complicated manner. Although the hexagonal panel is done, but different shape is also possible. Detail design front view. V design of different variants. Different variant accounts for different range of power supply to the satellite. Possible variant of the MVSPDS is given below. 6 stages of deployment. Different stages of deployment are given below in a tabular form. Acknowledgement. I take upon this opportunity to acknowledge such people whose participation and help has played an integral part in completion. This research project with flying colors. I am deeply indebted to my Autodesk 360 team for helping me with this project with proper guidance. I would like to thank our Honorable Head of the Department, Aerospace, for furnishing us with proper reasoning and knowledge, helping and supporting me at every moment. I owe my sincere gratitude towards other faculty member who cordially gave ideas regarding the paper. My heartfelt thanks to the lab assistant who has provided us the required information in crucial time. I also express my deepest gratitude to the institution for providing us the opportunities for such interesting paper and file a patent on it. Finally, I would like to wind up by paying my heartfelt thanks to all faculty member who has helped us in doing this paper and to the institution for providing us the opportunity for such enthusiastic paper. Last but not least, I want to express my special regards and thankfulness to my family for their great and continuous support and motivation without my research paper, without whom it wouldn't have been possible. Conclusion. From the above design it can be concluded that the design is a unique design which is not only having multivariant structure, but also having wide range and dynamic performances. It is clearly depicted from the design that the structure is very compacted during the process of orbit insertion. Yet when it come into working it definitely works according to the need of the satellite. For an example, when the satellite needs less amount of light it will transform itself in such a way that the amount of power generation will be less. On the other hand, when the satellite needs more power, then the solar panel will change itself in such a way that it will have the maximum surface area, as a result of which the power generation will be maximum. Moreover, the variety which provides is really unique, as it also has the power to change its solar panel into different structure. For an example, it can change itself into a circular structure, it can change itself into a canister form, and moreover it will work completely according to the need if programmed properly. And hence can give rise to a wide variety of different deployment methods for solar panels in space.